copper chlorine cycle is the thermochemical cycle that uses thermal energy to generate clean, emissions-free hydrogen fuel. In this presentation, we hope to give you a basic understanding of the copper chlorine cycle, its potential applications in the clean energy industry, and the current status of development. Abbreviated as the CuCl cycle, the copper chlorine cycle uses salts of copper and chlorine as intermediate chemicals to perform a series of thermochemical reactions which split hydrogen and oxygen from water. These salts later decompose and recombine, releasing the hydrogen and oxygen as products. The copper chlorine salts are recycled continuously to be reused in the cycle. As a result, the CuCl cycle does not contribute to any added CO2 or other greenhouse gas emissions. The copper chlorine cycle begins with the reaction of steam with the salt copper-2 chloride at 400 degrees in a two-phase reactor, known as the hydrolysis reactor. This reaction allows for the copper-2 chloride to liberate a chlorine atom and combine with oxygen from the steam, forming a solid compound, commonly referred to as copper oxychloride. The remaining hydrogen combines with the free chlorine to form hydrogen chloride. The copper oxychloride salts are removed from the hydrolysis reactor via solid conveyors and deposited into the thermolysis molten salt reactor. In the thermolysis reactor, the copper oxychloride is heated to its melting point at 500 degrees, causing oxygen to be released and forming molten copper-1 chloride as a result. The oxygen can be collected for use or vented to the atmosphere after being cleaned of any chloride vapors. The resulting molten copper-1 chloride is quenched into solid particles in a quench cell and transported to a dissolution cell, where the hydrochloric acid from hydrolysis is used to dissolve the copper-1 chloride. Copper-1 chloride and hydrogen chloride react together in the electrolysis reactor, forming copper-2 chloride and hydrogen ions. The hydrogen ions combine to form hydrogen gas, which is collected at a gas-liquid separation point in the vessel. The resulting copper-2 chloride is transported back to the hydrolysis reactor, beginning the reaction anew. Now that we understand what the copper chlorine cycle is, let's understand why the copper chlorine cycle is being developed. By operating on thermal energy, the copper chlorine cycle can be employed to use either dedicated thermal sources or waste heat. This avoids the compounding inefficiencies of thermal power generation used to provide energy for electrolysis-based hydrogen production. Compared to other thermochemical hydrogen production cycles such as the sulfur iodine cycle, the copper chlorine cycle requires a lower operating temperature, allowing for a wider range of energy sources to be used. Finally, the copper chlorine cycle can utilize a wide range of waste heat sources, including industrial waste heat, nuclear energy and waste heat, and concentrated solar energy. The copper chlorine cycle has been proven as a series of lab-scale experiments, as well as together in an integrated lab-scale loop. In order to bring the copper chlorine cycle to market, the next step is to develop and deploy a pilot-scale hydrogen production plant using industrial waste heat. This pilot scale is currently planned to be capable of producing 5 to 10 kilograms of hydrogen per day, depending on site capacity. Once a pilot plant can demonstrate design feasibility, the copper chlorine cycle will be ready for full-scale commercial production. Thank you for taking the time to watch this video. We at Ontario Tech University hope that you found this to be very informative. If you'd like to learn more about the copper chlorine cycle, please contact Professor CuCl Gabriel at the email address camille.gabriel@ontariotechu.ca or by phone at 1-905-924-2232. Thank you.